we had this situation where it went high up to the right. Now we have this situation where it goes high up to the left. And in fact, let's go ahead and put that other one back on here. Okay, this one technically was G. Here's F. That was our previous one. Okay, and you can see they're different shapes, right? The one with the 6 is steeper. We'll talk about why in a moment. But we can see the general idea is similar. They shoot upward, either shoot upward on the right, like when it was 6 as the base, or shoot upward on the left, like when the base is 3/4. Okay, so let's talk about why that 6 was steeper. It's just because if you multiply by 6, that has a bigger effect than multiplying by 3/4. If I instead did 1/6, okay, so let's put up y equals 1/6 to the x power. Okay, let me put parentheses around this. Okay, and compare that to y equals 6 to the x. And we see they're perfect reflections of each other, and that's because they have the same growth rate, just going in different directions. For y equals 1/6, you're dividing by 6 as you move to the right. In other words, as you move to the left, you're multiplying by 6. And for y equals 6 to the x, you're multiplying by 6 as you move to the right, which means as you're moving to the left, you're dividing by 6. So you can see they're just reflections of each other. Okay. So let's go back to the g of x that we're looking at. G of x equals 3/4 to the x. If you were to plug in really, really large values for x, we would get a really small value for the output. The reason why is because, sure, 3/4 is close to 1, but it's still smaller than 1, right? If I say I'm going to multiply my bank account by 3/4, what that means is I'm going to have slightly less money in my bank, okay? So what this means is as x increases, y decreases. We're multiplying by 3/4 every time we move to the right. So multiplying by that more and more and more is going to shrink your output. It's never going to get to 0, but it's going to get smaller and smaller and smaller. And so what that means is we actually, yet again, have a horizontal asymptote at y equals 0, in other words, the x-axis. Okay, and I'll do the same thing I did before, make it bright red and thick there. Okay, so we can actually go up here and we could say this same exact thing we said before, except change 6 to the x to 3/4 to the x. Okay, so let's change this 6 here to 3/4. Okay, the other thing we have to change is this time it's as we move to the right instead of as we move to the left, so that means x is approaching positive infinity. X is increasing. Okay? So it's still an asymptote, it's just we're approaching it when we move the opposite direction, and we're approaching it slightly slower than before. With the base being 6, we approached it a lot faster. Okay, let's return back to our textbook. Okay, and you'll see that over here on the right side of this little table, that we get the generalization again, but this time for values between 0 and 1 for our base. So when our base is a positive number that's less than 1, we get this other shape. It's still concave, but now it's approaching infinity on the left side. It's getting really big on the left and approaching the x-axis, approaching 0 on the right side. So again, we still have an asymptote. It's actually the exact same asymptote as before. We're just approaching it in a different way. And this is an example of what's called exponential decay. Okay, some people just say negative growth, but usually instead of negative growth, people like to say decay. So this is an example of exponential decay. Okay, so we've now covered the two main types of exponential functions, those with growth and those with decay. Now, over here, the book switches to talking about how you can look at what happens when you change the input a little bit, when you add one or subtract one to the input. Okay, let me just quickly show you what happens. Here you can see the original version is the blue version. Actually, if you happen to be colorblind, the blue one is this one right here. Okay, that's the original one. That's f of x equals 2 to the x. And then when you add 1 to the input, what that means is everything happens 1 unit sooner, right? You're adding something at the very beginning, so everything happens sooner. So that means you shift everything to the left once. And so now we have this red curve, which is this one right here, okay? And it's 1 unit to the left of the previous one because everything's happening a unit sooner, okay? So that's something that you can try on your own for looking at what happens if you subtract 1 and if you add 1 but with a different base. For example, did this shifting of 1 depend on the fact that the base was 2? If you change the base to 3, does it still shift the exact same way? I'll let you figure that out. Okay, you can also do changes by affecting the output value. Okay, in this case, I'm using the example in the book for these because it just takes too long to draw them out individually and have it look nice. So we're looking at these in here. So in here, notice this time there's an adjustment again, but instead of being an adjustment to the x value, it's the adjustment to the output, which is the y value. And so what that means is at the end, you're taking 2 away from the y value, so everything gets smaller by 2. So in other words, everything shifted down 2 units. So you can see, again, the original one is this blue one here, okay? The top one, if you are colorblind. And then everything got shifted down 2 units. Okay, everything in this red curve, which is the lower curve, is 2 units below everything in the top curve. And the thing is you didn't have to know that going into it. If you were to actually plug in values, you would end up seeing that exact same thing. When x was -2, f of x was 1/9. When x was -2, g of x was sorry, did I say -1/9? It was +1/9. When x is -2, g of x is -17/9, which is the same as -18/9 below 1/9. 18/9 is 2. So when we say -18/9 below that, what that means is we're talking about 2 units below. Okay. And again, you can try it on your own, seeing what if you change that -2 to a +2? What do you think that's going to do? Okay, think about that and then try it and see what you get. And then again, what if you still subtracted 2, but your initial function was different? Instead of a 3 to the x, you had a 4 to the x. Does that change anything, or is it still a shift downward of 2? Think about that and check yourself.